All right, good morning, everybody. This is lesson 17A, page 12 of your Unit 3 packet. What are functions and how do we identify their key features? All right, so I'm going to go through the do now with you. If you want to take the time to try to answer it yourself, pause the video here. And then if you want to check your work, press play after you're finished. Okay, so let's get started. Which graph represents a function? So if you remember what a function is, it has several indicators that a graph could be a function. The first one is if you're looking at it, it can pass the vertical line test, which is a hint that I provided for you guys in this corner here where I'm drawing the arrows. All right, I made a mistake on your packet actually, and I wrote horizontal line test instead of vertical. Let me do that. Sorry, I'm new to this. Okay, so there's the hint. So vertical line test, right? So vertical line means that it's going up and down. So if I was to draw a vertical line on each of these graphs, if it touched the graph more than once, that means it is not a function. So I can rule out answer choice 4 because it's hitting the graph here and here in multiple places. All right, now let's try a vertical line to here. If I just drew one vertical line at this point, it would only touch this sideways parabola once. But if I continue to draw a vertical line in multiple places, then you would see that it's hitting the graph in more than one place, which means this is not a function. All right, answer choice 3. I'm drawing my vertical line, and it's hitting the graph in more than one place. All right, so answer choice 3 is not it, which leaves us answer choice 1. All right, so let's see. If I draw a vertical line in more than one spot, I see that it doesn't touch the graph more than once. So answer choice 1 would be the correct answer. So in the how do you know box, it passes the vertical line test. All right, during the rest of this lesson, we're going to get into how else can we tell a graph is a function. Okay, so moving on. A function is a relation in which each element of the domain corresponds to one and only one element in the range. All right, so let's talk about that for a second. All right, so I highlighted one and only one element, and I should have also highlighted in the range. So this means if I wanted to identify by looking at a table of values, if my graph is going to be a function or not, that means that my x value is only going to have one y value, right? So if I say 2, 3 is a coordinate, then 3 can only be the y value for an x value of 2. All right, 2 cannot have another y value of 5. All right, because it already has a y value of 3. So that's just explaining the one and only element in the range value. Okay, so if I give you an input, you need to be able to tell me what the output will be. All right, so for the first example, determine if the following table represents a function. Okay, so x is 1. So if my output, and you're going to write this in, if my output is 1, my output, if my input is 1, my output is 0. All right, and if my input is 2, my output is 5. If my input is 3, my output is 1. But now I have this last coordinate point, right? This one here. And it says if my input is 2, then my output is 3. All right, so now I see that I have 2 y values for 1 x value, which tells me that this x value is repeating. All right, that means I'm going to see this x value more than once on my chart, which I do right here. Excuse me. So, is this a function or not? Please pause the video here to fill in the box on the right. Okay, and this is not a function, so that is what you're going to fill in. Is not a function because the x value of 2 repeats. Sorry, y'all, my daughter just woke up. Okay, so next is the you try example. Pause the video here so that you can answer the question on your own, and then I'll go over it with you as soon as you press play. Okay, so for the you try, if my input is 2, my output is 10. If my input is 5, my output is also 10. If my input is 6, my output is 8. If my input is 7, my output is 2. So I want you to notice, well, hopefully you already noticed if you did this on your own, that none of my x values repeat. I have 2, 5, 6, and 7. All right, now it is okay that my y value is repeated. Okay, that's perfectly fine. And it's also great that my x values did not repeat because this tells me that this is a function because my x values do not repeat. Okay? All right, you have 2 practice questions that follow this page. You can do those on your own. Remember, this packet is being collected once we return to school in April. So all the practice questions you do on your own will be graded. Okay, so key features of functions. So we're going to discuss x-intercepts, y-intercepts, yes. And another name for x-intercepts can be called roots or solutions or zeros. So in this section, I want you to fill in, we also call these roots. Sorry, get my pen. Or zeros. Okay, so discussing key features of functions. We have absolute maximum, absolute minimum, relative maximum, relative minimum. Okay, so let's use red. So identifying the y-intercept. All right, so that's where you wanted to cross the y-axis. That's this point here. Okay, every y-intercept has an x value of 0. So that's going to be 0, 2. Clear. All right. And don't touch, every root or 0 or x intercept is with. Okay, so as I was saying, x-intercepts are where the graph crosses the x-axis. Okay, so let's choose another color. That will be here and here. And you're going to label these points. All right, so my key features are not on the same page. So I'm going to label on my graph. And as I'm doing that, Wait, where my graph? Oh. And as I'm doing that, I want you to write it down because you have everything on one page in your packet. Thank you so much. All right. So this point on the x-axis, the y value will always be 0. And my x value will be 4. Okay. And for this point, this is the negative side of my x-axis. All right. So I'm just labeling what's negative, what's positive. This would be 1, 2, 3, 4, 5, 6. So this would be, hold on, negative 6, 0. Okay. So now, if I wanted to continue labeling, which I will, my absolute maximum, right? So the word absolute gives this a different meaning than relative. Absolute means it is the very highest point on your graph. All right, now there's clearly multiple high points on this graph. So you see it go up the first time and then it goes higher up the second time it moves. Okay, so the absolute maximum would be this point here. Now, if you decided to go on and do this on your own and you thought it was this point, still close, but not it, this would be a relative. Okay, so this is the absolute maximum, and this would be your relative maximum. Okay, so this absolute max point is at 2, I believe 10, 2, 8. So 2, 8 is our absolute max. And then our relative max, which is here, is a negative 4, positive 6. Okay, negative 4, 6 is our relative max. All right, now let's choose purple. And let's talk about our absolute minimums and our relative minimums. So, just to reiterate, absolute, if the word absolute is in front of maximum or minimum, there's only one of these. There's only one absolute. Let me make that in blue. Only one. Now, although there's only one relative max for this particular graph, there can be more than one relative anything, relative maximum or relative minimum. But again, if the word absolute is there, there is only one that can be the highest or the lowest point on the graph. Okay? So now we're using purple. So we have multiple minimums. We have a minimum here, we have a minimum here, and we have a minimum here. All right, so I want you to look at these 3 purple dots that I just identified on the graph, and you tell me which one is the lowest, the one to the left, the one in the middle, or the one to the right. So the one on the left is the lowest. So that is our absolute minimum. All right, and this point is -8, -4. All right, now I know some of you have sometimes issues with graphing or getting your X and Y's confused. Notice that I have the X and Y value labeled for these axes, and then I also went ahead in green and put which side of the x-axis is positive, which is negative, and which side of the y-axis is positive and which is negative. All right, so now that we have our absolute minimum at -8, -4, we're going to tell which points are our relative minimums. Because if it's not absolute, then it has to be relative, right? Because there's only one absolute minimum. So here we have a relative minimum. All right, and we're going to count. So 1, 2, 3, 4, 5 for our x value, and how many down? And that'll be -2 for our y value. Okay? And then the relative minimum here, this point is over -1, up +1. So that's -1, 1. Okay, for this relative minimum in the center. All right, so I believe we've identified all the key features of a function. So you can fill that in at the bottom of your page, and then you have a U-try. So I want you to pause the video here for your U-try. Okay, so if you use my example as a guide, you definitely should be fine. All right, your U-try, the questions are pretty much the same, but a little bit more specific, okay, than given the general coordinates for the key features of a function. So again, we have our x and y axis labeled, x and y. I'm going to go ahead and identify that this side of the x axis is positive, this side is negative, this side of the y-axis is positive, and this side is negative. So just to start off, you can identify all of the key features in the beginning so that it helps you answer the questions below. Because if you identify everything as far as the key features are concerned, then you'll have the answers you need for the questions below, whether they asked it or they didn't. Okay? So first thing we want to look for, let's say x-intercepts, right? Because there's a lot of them. So let's start with this. So we have the x-intercept here, x-intercept here, a root here. Remember, those are the same thing, or a 0 here. All right, it can be called x-intercepts, roots, or zeros. So 1, 2, 3, 4, 5 x-intercepts. Okay, so then we're going to go ahead and label them with their coordinate. I believe this is an 8 by 8, but let me just make sure. 1, 2, 3, 4, 5, 6, 7, 8. It is. Perfect. Okay, so let's start with the last one on the left. Remember, this is a negative side for the x values. So this is going to be -7. And remember, every y value for your x-intercept is going to be 0. So all you really have to do is find what number the x value is at, and then that's it, because your y value is 0. So 5. So this is -5, 0. And this is -1, 0. Okay. 3. This is, let's go up here, 3, 0, because I'm in the positive side. And this is 5, 0. Okay, perfect. So the x-intercepts have been labeled, and I'm just going to write x-intercepts over here so I know I did that in blue. All right, so now let's go to red, and we're going to label our y-intercept. So we only have one y-intercept, and for y-intercepts, the x value is always 0. So this is the positive side of the y-axis. So this is 0, 3. I'm writing y-intercept over here because we labeled that 0, 3 in red. Okay, so moving on, green. Now we can label our absolute. I'm going to do the absolutes in one color and all the relatives in another color. Hopefully that's not too confusing, but we'll see. So our absolute maximum. So that will be here in green, okay, the highest point. So in green, absolute, and I'm writing shorthand. Sorry for the pop-ups. This is my first time doing a video. Absolute maximum. Okay, awesome. So this point is on the positive side of the x values and the positive of the y. Okay, so hop over, we go 1, +1, and the y value would be 2, 3, 4. So 1, 4 is our absolute max. Now for our absolute min, the lowest point, absolute minimum. This point is on the negative side of our x-axis and y-axis. So 1, 2, so that's a -3. And our y value is 1, 2, 3, 4. So -3, -4 for the absolute min. Okay? And now let's use purple. And purple will be for all of our relative maximums and our relative minimums. All right, so like I told you before, the absolute max and absolute min, there can only be one. But there's more than one relative maximum and more than one relative minimum. All right, and here we have an example of more than one relative maximum, because in the example I went over with you, there wasn't. So there's a relative maximum here, and there's a relative maximum here as well. Okay, so this point here would be +8, 3. Okay, because I'm going over to the right 8 units and then up 3 units. Yes, awesome. All right, this relative maximum here, excuse me, would be 1, 2, 3, 4. So that's -6. And the y value would be a +2. So -6, 2. All right, relative maximums. And then next we're going to do relative minimums. Okay, so we have a couple of relative minimums as well here. And one thing I want to point out, this relative minimum here and this, relative maximum here and this relative minimum here, just because it's the end of a graph doesn't mean it's not a part of a key feature of a function, okay? It's still a part of the graph, so you have to count it for what it is, all right? So the start of this graph became a relative minimum. The end of it became a relative maximum. All right, so this point here, we have negative x and y axis here. So that's going to be -8, 1, 2, 3, -3. Okay, so that's everything that you can identify as far as the key features are concerned. So let's scroll down and see what the questions are actually asking you. So the first one, find all the relative maximum values. State the values of x where they occur. So we found all of the relative maximum values, but they don't want the coordinate points. They only want the x values. So yes, it's perfect that we went and found those, because now we can just go back to our graph and look up and see what all of those would look like. So relative maximums, probably should have did these in different colors, but it's cool. Relative maximums, I'm looking at the top of my graph for purple. I see 2, okay? Let's highlight those. All right, so I have a relative maximum x value here and a relative maximum x value here. So I'm going to write it as a solution set. Okay, now we talked about this. We talked about set builder notation with inequalities and how you would write your answers. Okay, so I'm going to put the squiggly bracket and I'm going to put -6, comma, 8. Now, what makes this different from a coordinate is because it doesn't have parentheses. But if you don't feel comfortable or feel like you don't remember to put the squiggly brackets when you're answering just for one set of values, which here we're answering for x values, you can literally just put x equals -6, x equals 8. Okay? Either answer would suffice. So now we're going to go to question 2. Find all the relative minimum values. state the values of x where they occur. I'm going to go back to my highlighter for my graph. Oh, and I did not tell you what the value of this relative minimum is, so let's talk about that really quick. 1, 2, 3, 4. Sorry about that. So this would be 4, -1. So sorry. All right, and if you caught that, you're amazing. Okay? So, highlighter, and I'm going to highlight the x values of all my relative minimum values. So I have one here at 4, and I have one here at -8. All right, so again, I'm going to write it in the solution set, and I'm going to put -8, comma 4. Yes, I tend to write it in the order it is on my graph, from left to right, or if you want to think about it, from least to greatest. Okay? And again, you can write it as x equals -8, x equals +4. That's also fine. Okay? So moving on, number 3, what is the absolute maximum of the function? At what x value does it occur? So this question is a little different from question 1 and 2. Question 1 and 2 said find the relative maximum or minimum values, then state the value of x. Number 3 asks for it says what is the absolute maximum on the function? That means they want you to tell them the coordinate. Then once you tell them the coordinate, what is the x value? All right? So that one is 2 questions in one, which is perfectly fine. We can definitely handle that. Okay, so I think I did absolute in what, green? So let's write our answer in green. Okay, so our absolute maximum was 1 +4. If you can see that here, absolute maximum was 1 +4, which means our x value is just 1. So in parentheses, 1, 4. And then I can still put the squiggly brackets if I want, but I don't have to. I'm just going to write, because it's one number, x equals 1. All right, then moving on, absolute minimum. I'm going to highlight that. Absolute minimum is here. Then I'm going to go down and write -3, -4. And that is at x equals -3 to answer question 4. Now, question 5, what are the x and y intercepts of the function? So that means give the coordinate pair x, y. List each of the following as an ordered pair. Okay? And just know x intercepts can also be named roots or zeros. Okay. And the x coordinates we did in blue. So there was a lot of them. Should I give myself more space? So -7, 0. -5, 0. And I'm putting this in a squiggly bracket as well. -1, 0. See that I'm putting commas in between my parentheses to let you know there's more roots coming. 3, 0, and 5, 0. 3, 0, in parentheses. And 5, 0 is the last one. All right, and y-intercepts, there's only one of them. And that's in red. Ooh. And that was 0, 3 in parentheses. Okay? So x-intercepts again, -7, 0, -5, 0, -1, 0, 3, 0, 5, 0. Y-intercepts 0, 3. All right, so moving on. So now we're on to the next lesson. The page before lesson 17B there's a challenge page. Please do not forget that your challenge pages count as extra credit on your quizzes. Although your quizzes are online, once graded, if you completed a challenge page, please take a picture of it and upload it to Google Classroom so that once I add that grade to Pupil Path, you can see the extra credit on top of the grade that you got from your online score. Okay, your first quiz is on Friday, March 27th, on what we did last week in school and what you've learned this week during your first online course. Okay, so it's going to have inequalities, it's going to have functions, it's going to have domain and range, it's going to have a couple things. I'm going to try to do 1 or 2 questions from each topic. Not a lot. Some of them may be multiple choice. Most of them will probably be multiple choice actually because I'm doing it online and it's just a little bit easier to go through. You'll have more than enough time to complete them and you can have multiple attempts to answer them and I'll take the highest grade on whichever attempt. If you're having any issues with taking the quiz, definitely email me, write me in Google Classroom. If you signed up for the Remind app, you can write me on there as well because it'll come to my phone as a text message. Okay, I am here for you if you need me. All right, so let's get started. Lesson 17B. If you want to start the do now on your own, pause the video here. Otherwise, keep playing because I'm going to go through the do now with you. Okay, so hold on. What are functions and how do we identify their key features? So in the last lesson, we talked about key features being the x-intercepts, roots or zeros, the y-intercepts, absolute maximum and minimum, relative maximum and minimum. Okay, so there are also other key features which are domain and range. All right, not everybody's favorite subject, but definitely something we've talked about in Algebra 1. Okay, you need this to help you move along in Algebra 2. All right, it's not something you can forget. It's a part of the curriculum. Okay, so in this activity, you will be exploring domain and range. In one sentence, explain what domain and range mean to you. Okay, now if you took it upon yourself to answer this question first, hopefully your answer contains that domain deals with the x values of a function or of a graph, and the range deals with y values. Okay, anything along those lines, you are spot on. Okay, so hold on. So domain of a relation, the set of all first elements of the ordered pairs, which is all x coordinates, and range of a relation, the set of all second elements of the ordered pairs, which is the y coordinates. Okay, so that's pretty much it for the do now. So we're moving on to the rest of the lesson. So pick the correct graph. Which graph has a domain of -2 is less than or equal to x, which is less than or equal to 4? All right, so I know looking at this, if you've seen it before, if you don't really remember it, it may be a little bit confusing when you first look at it. But all of this is talking about is which graph says that the x values are starting, right? Because remember, you read from left to right. It's the same thing with graphs. Which is starting at -2 and ending at +4. And keep in mind, I gave you all a cheat sheet. It was a yellow and green piece of paper that I told you to keep in your blue packet. So you all should definitely have it. All right. The equal to on your inequalities tells you that you should have a closed circle. All right. So let's just look at all of these graphs. Sorry, I keep moving that bar over. So all of my graphs have closed circles. So that's not something that can help me rule out which one of these is the correct graph. Okay? So now let's look at the x values. Now, my scale is labeled very generally. Okay? It's labeled with a 5 on the y-axis, a 0 at the center, and maybe a 5 on the x-axis. Okay? So yes, so with that being said, okay, so with that being said, let's take a look. So this is starting at x equals 1 and ending at x equals +4. That's not what we're looking for, right? We're looking for, this is starting at -1, x equals -1, and x equals +4. We want it to start at -2. All right, so this is not a graph that represents the domain given to us. All right, the graph on the right, this one here, it's starting at x equals -2, and it's ending at 2. It's ending at x equals +3. Again, we want our graph to end at +4. So this is not the graph we're looking for. All right, now moving on to the bottom left. We're starting at x equals -2, and we're ending at x equals +4. That is what we're looking for, but let's just make sure the last graph does not give us what we need. We're starting at x equals -1 here. We're ending at x equals +3. So no, we definitely have the graph we're looking for on the bottom left. Okay? As long as it's starting and ending where the domain they gave us, which is here. All right? I know I'm doing a lot of highlighting, okay? But if it matches that, then you're definitely correct. And the only graph that does is the one on the bottom left. If you answer that on your own, again, you're amazing. Okay, so next question. What is the range? The range, again, deals with the y values. Okay? So let's keep that in mind when we're looking at this. I know looking at a graph, sometimes your eyes may want to go to the x values, but see how the graph is highlighted green? It's only focusing on what the y values would be, where it's starting and where it's ending. Notice that we have closed circles on this graph. So all of our inequalities have an equal to, okay, because the circles are closed. So let's just look at the graph first instead of looking at the answer choices so we can see what we can rule out. All right. So if you're reading from left to right, left on the left side, as we go left, we begin to hit -5 at this point. All right. If we continue, the last number that we hit is 0 for this graph. So that rules out answer choice 2 and it rules out answer choice 3 because we do not start at 0 and end at 4. We start at -5 and end at 0. All right. And again, our range talks about y values. I see that the last answer choice has an x in the middle, which means that's talking about domain. And here, we're not talking about that. We're talking about y values, so that leaves us answer choice 1 for this question. Okay? Okay, so this is talking about domain and range again. What is the domain of the graph to the left? So remember the way they wrote the domain, not on this page. Well, yeah, the last question, which is here. All right, I'll just make it a star. This is the way they would like you to write domain again for this question. So where is it starting? And remember, you're focusing on the x values here. And where is it ending, which is here. So I know that I'm writing -6 and I'm writing +2. All right, I'm starting at -6, ending at +2. I also see that we have open circles here and here, meaning that my inequalities will not have an equal to. An x value will go in the middle. All right, when you're writing domain and range, know that your inequality symbols do not change. When you're writing it this way, there'll always be less than. Okay, now again, since there are open circles here, there's no equal to, so this is my domain. -6 is less than x, x is less than 2, which is telling me my graph lies between x is -6 and x is +2. All right, and it's as simple as that. I want you to try the next 2 questions on your own. Those are your practice questions. This is how they look. this one here, you can write on your own. Remember, if you're writing range, that Y should be in the center. And you're writing the range based on this graph. And then this one, it says check all that apply for the graphs that have domains that are all real numbers. All right, we talked about that slightly. All real numbers meaning that it has a negative, it goes to negative infinity and positive infinity. So it touches all the negative x values and all the positive x values. All right, and because it says check all that apply, means that there's more than one graph here that has a domain of all real numbers. And when I say we talked about this before, in interval notation, it could look like this. All right, with the number line, we talked about it going from negative infinity to positive. If it has arrows on both ends, that's an indicator that it's going to continue on forever in both directions. If it has dots, that means it is starting or stopping somewhere. All right, so be careful with that, with whichever one you choose for this. But there is more than one answer here. Okay? And that's the last for this lesson, 17A and B. I will have the videos continuing to be posted on Google Classroom as the week continues on. Thank you so much for listening. Again, if you have any questions, write a comment or email me personally. Have a great day.